All right, section 6.2, day 1 is on polynomial functions. A function is where all exponents are whole numbers and coefficients are reals. That is what designates a polynomial function. So for example, negative 7x to the third plus 9x squared plus 11x to the fourth minus 13 plus 4x is a polynomial function because any coefficient or number that's in front of a variable is a real number, and all exponents are whole numbers. So let's talk about some of these new terms. The degree is the highest exponent. Okay, so the highest exponent in here is 4. So the answer for degree is, it's the fourth degree. The degree is 4. Standard form is when you put exponents biggest to smallest. So they go in order from biggest to smallest. So the biggest exponent is positive 11x to the fourth. The next biggest exponent is negative 7x to the third, so minus 7x to the third. And then the next biggest is 9x squared. And then 4x. And then minus 13. So 11x to the fourth minus 7x to the third plus 9x squared plus 4x minus 13. Notice the exponents go from 4 to 3 to 2 to 1 to no variable. The leading coefficient is the coefficient with the biggest exponent. So in this case, the leading coefficient is 11, because the biggest exponent is x to the fourth, and the coefficient in front of that is 11. And the constant, zoom in a little bit, is the term without a variable. So in this case, the term that does not have a variable is negative 13. And it will come at the end of standard form. The constant is always at the end when the polynomial is in standard form. So we have degree, standard form, leading coefficient, and constant. Okay, some common types of polynomials. When the degree is 0, this is called a constant. And it would be like f of x equals 4. This is our example. And what the graph would look like is it would just be a horizontal line. Okay, and just recall f of x equals 4 is really the same as y equals 4. So it'd be a horizontal line. When the degree is 1, it would be linear, and it would look like this: y equals 2x plus 1. And the graph would be some sort of a line. Might be going up, could be coming down. The slopes may vary, but it's going to be a line. When the degree is 2, that's called a quadratic. So y equals x squared minus 3, and a quadratic will be a U-shaped graph. It could be a U-shape going up, it could be opening down, but quadratic is when the degree is 2, so the biggest exponent is the second power, x squared. Okay, the third degree would be called a cubic. Okay, and a cubic would be like x to the third plus 3x. The biggest exponent is 3. And a cubic would look like this. It'd be a graph that kind of looks like a snake. It swirls around a couple times, and they go in opposite directions. The arrows, one goes up, one goes down. The fourth degree is a quartic. So y equals x to the fourth minus 5x to the third minus 7. The biggest exponent is 4. And this one will look something like this. It'll come down and make a couple loops, and then in the end it goes in the same direction. So both arrows go up, both arrows might go down, but the arrows definitely go in the same direction. And the last one we're going to talk about is a quintic. I mean, they go on and on, but the quintic is the last thing we'll talk about, and that's when the highest degree is 5. So like x to the fifth is the biggest exponent. And this one will look like this. It'll come up, down, and up. So it'll go in opposite directions. And if you notice, the number of times the direction changes, that will match the degree. So like this one goes up, and then down, and then up, and then down, and then up. 5 different times that changes. In the graph above, it comes down, then up, then down, then up. 4 different times that one changes. For a cubic, when the degree is 3, this one came up, and then down, and then up. So look at up, down, up, 3 changes. When the degree is 4, it's down, up, 4 changes. And the quintic was up, down, up. There were 5 changes in direction. So the degree just tells you how many times will that graph change directions. And then a couple examples says, decide whether the function is a polynomial function. If so, write it in standard form, state the degree, type, and the leading coefficient. So in number 1, is it a polynomial function? The answer for this is no. And the reason why it's no is because there's a negative exponent. If there is a negative exponent, it is not a polynomial function. Okay, so we're not going to worry about putting in standard form and the degree and all that because it's not a function. So we're not going to do all that. The second part, this is a polynomial function because all of the coefficients are real numbers and all of the exponents are whole numbers. So standard form would be f of x equals 7x to the third minus 0.8x squared plus 5. The degree is 3 because the degree is the highest exponent. So if you look here, the highest exponent is 3. The type, since the degree is 3, the type is called a cubic. Okay, and that's from up here. 3 means it's a cubic. And the leading coefficient is 7. Okay, so we have cubic, leading coefficient, the degree. We can find all that stuff out when we put this in standard form. Okay, so that's the new definitions that we're going to cover. And the last part of the notes, we're going to talk about substitution and the different types of substitution there are. So we can do direct substitution or synthetic substitution. And we're going to talk about the difference right here. So direct substitution is the substitution you've done your whole life up to this point. So if we have the function, it says, what is the value of the function when x equals 4? So what we do is we take 4, and we put that 4 in wherever we see an x. So we take that 4 and we directly put it into the function. So anywhere there's an x, we replace it with a 4. So we end up with f of 4 equals 5 times 4 to the third is 320. And make sure you actually get that on your calculator so you know you're plugging that in right. Minus 3 times 4 squared is 48. Plus 14. So f of 4 is 320 minus 48 plus 14, which is 286. F of 4 is 286. So we got that from plugging in to our function. And just a reminder, we don't have to solve for f. We're not dividing by 4 here. This means when you put in 4, you get 286. It's input-output. What's new is synthetic substitution. This is different. This is new for us. Okay. For synthetic substitution, we have to put something in for every term or variable. So do you notice how this goes from x to the third to x squared to 14? We're missing a plain old x. So what we have to do is we need 0x because there are 0 x's in this equation, this function. So this would be f of x equals 5x to the third minus 3x squared plus 0x plus 14. And how synthetic substitution works is you take the number that you're trying to evaluate, and that kind of goes up in this top corner in what I'll call a box. And then we put every coefficient in order. So the first coefficient's 5, then -3, then 0, and then 14. And this is why we needed to put in a 0. Because if you don't, it's going to mess this up. So here's how synthetic substitution works, which is something we're going to need later on. You bring down your first coefficient, the leading coefficient. And what we're doing is we're taking every number down here times 4. So 4 times 5 is 20. And then we put 20 in that next blank. We add these up. -3 plus 20 is 17. All right? Now it's 4 times 17. And that goes in the next blank. And then we add these up. 0 plus 68 is 68. And then we do 4 times 68 is 272. And then 14 plus 272. Again, we're adding these up. And you would get 286. And that's pretty neat. Like, it's kind of cool how this works out, but that's how synthetic substitution will always work. We get the same number you got doing direct substitution. These numbers are the same, 286. Okay, and let's try one more. Look at number 3. Let's do direct substitution first. So what is it when x is -1? So 3 times -1 to the fourth plus 7 times -1 minus 1. So f of -1 equals 3 times -1 to the fourth is 3. 7 times -1 is -7. So now we have 3 plus -7 minus 1, and we get -5. So when we put in -1, we got -5 by direct substitution. Okay? So that's just plugging it in, find out what you get. Synthetic substitution, which is that new thing now, the tricky part here is remember to put in your zeros. So we have 0x to the third, and there is a 0x squared that we have to add in here. So So this would be f of x equals 3x to the fourth, and then there's a 0x to the third, a 0x squared, and then we have 7x minus 1. So we put the zeros in where they belong, and what we're trying to do here is make sure that there's no gap. So we go from 4 to 3 to 2 to 1 to no x's. We don't want to have anything skipped. So you put -1 in that box. And now we list the coefficients. 3, 0, 0, 7, -1. Bring down the 3. And remember, everything is being times. So this is times -1. So -1 times 3 is -3. And then we add, and now we have -3 on the bottom. -1 times -3 is +3, and we add, and we get 3. -1 times 3 is -3. You add and you get 4. And -1 times 4 is -4. When you add them, you will get -5. So if you look, we got the same number doing both types of substitution. Synthetic is just new, it's different, but we do need to know it later on. So that's what we got for today.